Have you ever looked up at the night sky, filled with countless tiny twinkling stars, and wondered what's out there? For thousands of years, humans have gazed at those same stars, telling stories and dreaming of other worlds. We used to think our solar system was the only one. Mars, Jupiter, Earth. But imagine each star is the center of its own family of planets. What if there are worlds made of diamond? What if planets have two suns setting in the sky? This isn't science fiction anymore, it's a real and super exciting field of science. Astronomers are like detectives for the cosmos. They use powerful telescopes, they use brilliant ideas. Okay, so what exactly are we looking for out there? We're looking for something called an exoplanet. That might sound like a complicated word, but it's actually really simple. The prefix exo means outside. So, an exoplanet is simply a planet that is outside of our solar system. For a long time, the only planets we knew about were the ones orbiting our sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Think of it like this. Imagine our sun is your house, and all the planets in our solar system are the people living in it. Then you look out and see other houses all down the road, each with its own family. Those other families are like exoplanets. Each star you see in the night sky could be a house with its own family of planets orbiting around it. These exoplanets come in all shapes and sizes, way more diverse and weirder than ours. Hot Jupiters, super Earths, ocean worlds, molten lava worlds. It's a cosmic zoo. The first confirmed exoplanet around a sun-like star was in 1995. Since then we've found thousands upon thousands, over 5,000 confirmed, and counting. Finding an exoplanet is not easy. It's like trying to spot a tiny firefly buzzing around a giant super bright searchlight from miles away. Exoplanets are incredibly small and faint compared to their huge bright stars. They don't produce their own light, only reflect a tiny bit. We can't just point a telescope at a star and see the planets directly. So how do scientists do it? They look for the small effects a planet has on its star. One of the main ways is called the radial velocity method, also called the wobble method. Imagine you are spinning a friend around while holding their hands. If your friend is small, you won't move much. If they're nearly your size, you wobble too. A star and its planet do the same thing. As the star wobbles toward us, its light shifts bluer, away, redder. This is the Doppler effect, the same thing that changes a siren's pitch as it passes. By measuring tiny regular color shifts, astronomers detect an invisible planet and estimate its mass and year. The bigger the planet, the bigger the wobble. Another super powerful way we find exoplanets is called the transit method. This one is a little easier to picture. Imagine staring at a bright lamp. If a little moth flies between you and the lamp, the light will dim just a tiny bit. The transit method works the same way. A planet passes in front of its star, and the star looks slightly dimmer for a short time. An exoplanet transit happens when a planet passes directly in front of its star from our point of view. Telescopes like Kepler and the James Webb Space Telescope stare at thousands of stars, measuring their brightness very carefully. They watch for tiny repeating dips, every 10 days or every 300 days, a huge clue a planet is orbiting. The time between dips reveals the planet's year. The amount of dimming tells us the planet's size. This method has been wildly successful. Kepler found thousands of candidates and showed planets are incredibly common, about one per star on average. Even better, starlight filtering through a planet's atmosphere can reveal gases like water vapor, methane, and oxygen, clues to habitability. Thanks to these clever planet hunting methods, we found some truly special places out there. One of the most exciting is Proxima Centauri b, Proxima b for short. It's our closest exoplanet neighbor, orbiting Proxima Centauri, only about 4.2 light-years away. Proxima b was discovered using the wobble method, detecting a tiny tug on its small, dim red dwarf star. It's a rocky planet just a little bit bigger than Earth in the star's habitable zone. However, Proxima Centauri blasts powerful flares that could strip atmospheres and bathe the surface in radiation. Still, an Earth-sized world next door is a huge motivator for exploration. Another mind-blowing discovery is the TRAPPIST-1 system. Imagine 7 Earth-sized rocky worlds around a tiny, cool star about 40 light-years away. At least 3, and maybe even 4, are in the habitable zone, with years lasting just days, and neighboring planets huge in the sky. When we talk about searching for life, we often look for planets that are habitable. But what does that really mean? Habitable usually means potential for liquid water on the surface. Too hot and water boils away. Too cold and it freezes. It has to be just right. The habitable or Goldilocks zone, which depends on the star. Big hot stars have zones farther out. Earth sits in ours. Venus is too close and scorching. Mars is on the cold outer edge. Small cool red dwarfs have close-in zones, so planets must huddle close to stay warm. Size matters. Too small like Mars and you lose atmosphere. Too big like Neptune and you get a gas giant. A good atmosphere and magnetic field help protect and regulate. We also look for the right chemistry, like carbon, and a stable, non-flaring star. With James Webb, we can study atmospheres and hunt for biosignatures, gases produced by life.